All right, period 8, guys. Today we're going to do the second day of sequences. Talking just about two different kinds of sequences. You'll have like a graded activity similar to the statistics one next class, but you can ask me questions and stuff before. It's not long. I'll probably give you like, whatever, 10 minutes to just like, have any questions you have ready. And homework tonight is also on Delta Math, and everything you can see is on Schoology as well. But take out your packets. You should have this to work with for the notes today, and then we'll get going. You get two videos, one on arithmetic sequences, and then the other one is on geometric sequences. So broken up into two different videos here. So arithmetic sequences, we're talking about specific types of sequences. You think if you were going to like plot them as a points, they would kind of fall in a line. So think lines as we do arithmetic sequences. So arithmetic sequences have what's called a common difference. So there's always going to be a difference in between one term and the next term and the next term. It's always going to be the same difference, right? And then they can be written in basically slope-intercept form or point-slope form. That's typo. But the common difference is basically would be the slope of that line, right? So you can mostly use point-slope form today, but you can think of it as slope-intercept form as well. And we'll give you that form in a second. And so example, right, the sequence whose nth term is 4n plus 3 is arithmetic, right, or arithmetic is what we call it sometimes. For this sequence, the common difference is blank. All right, so if we think about it, it says right there, the common difference is basically going to be the slope if you see it written in this form. So the fact that it's like mx plus b form, we know that this is kind of like a line if it was x and y. It's not a line because you don't connect the points, but it kind of looks like a lines format. That's what tells me it's an arithmetic sequence. And basically, the common difference is the same thing as what the slope would be. So if the slope would be 4, the common difference between each term is 4. We can break this one down a little further, right? So the first term in this sequence, right, the same thing as yesterday. If I need the first term, I plug in 1 for n. So 4 times 1 plus 3 would be 7. So the first term in this sequence is 7. The second term, again, if I want to find the second term, I plug in 2. So 4 times 2 plus 3 would be 8 plus 3, which would be 11. And so you can see the common difference is 4. It goes from 7 to 11 without even plugging in 3. I'm going to guess that the next term is going to be 15 because they keep going up by 4 if the common difference is 4. But notice how if I did plug in 3, right, I'd have 4 times 3, which is 12. 12 plus 3 is 15, right? But if you know it's an arithmetic sequence and you know the common difference, get the first term and then just like add that number or subtract it if it was negative, right, to each term. And that's as simple as it is, promise. So you really only need two values to find a common difference, like here, but like whatever, you can plug in a different one. You get the fourth term by plugging in 4, or you can get the fourth term just by adding 4 more to that number. But that's it, right? So practice. I want you guys just pause the video, do these two, and then resume the video when you're done doing it. And you can work with the people around you. All right, this one says a sequence whose nth term, 7 minus 5n, is arithmetic, right? We could probably figure that out just by looking at it. I may reverse the terms and say negative 5n plus 7 so that I see it as like mx plus b form, but just written in a different form. But it's still a line if it was going to be graphed. So that tells me it's an arithmetic sequence. They didn't have to tell me that. But for this sequence, the common difference is, and you can see the slope of that line would be negative 5. So that first term would be one number, and then it would go down by 5, down by 5, down by 5, on and on and on. This sequence whose nth term is 1/4 n plus 3. Again, it doesn't look like a line, but if I distribute out the 1/4, I can think of it that way. So I see it in like mx plus b form, 1/4 n plus, what's going to be 3/4, but that number doesn't really matter that much. But you can see here the common difference would be the slope, and the slope would be 1/4, which just means each number would be 1/4 bigger than the prior term. And that's it. And then if you need to find the nth term, so just working backwards, like you can figure out all the term numbers if I give you the nth term. If you need to write the nth term, we did this yesterday too, you want to think of it as like mx plus b form, but probably mostly going to be in point slope form because it's going to be easier this way. This b doesn't really make a lot of sense for us when we think about sequences and series, but this form does, right? So quick practice. Find the formula for the nth term of an arithmetic sequence whose common difference is 3 and whose first term is 2. All right. So you might think, oh, common difference, that's slope. I can plug in slope in there for m. First term is 2. That's going to be like my b. Well, it doesn't really work that way because technically a b is like a y-intercept, so the x value is 0. That would be like the 0th term, and that doesn't really make sense. So that's why I said this is probably going to be your formula here with point slope form. And you don't even have to simplify it, kind of just keep it the way it is. So, right, it's y minus y1. So again, the first term means like that's like an x value of 1. Now it's really an n value of 1, but we're going to think of this in terms of lines with x's and y's instead of n's and whatever the a value is, right? So in this case, I know that my common difference is 3. That's the same thing as like my slope. So I got my slope, right? So I'm going to say like, all right, well, I got y minus y sub 1 is going to equal 3 and then x minus x sub 1, right? And so if you remember, like these y sub 1, x sub 1, that's like a coordinate point. Well, I know that the first term, right? So first term, that's like my x sub 1. I can plug in like 1 for x. And I know that the value is going to be 2, so that's like the y. So my formula could be, y minus 2 equals 3, and then x minus 1. Right? And that's if it was a line. Now again, these are not lines, so we don't want x's and y's. I'm going to actually replace them with a sub n's and n's, but we can start with the y's. I know it seems confusing, but we're going to get rid of these in a second. But what I want to do is probably get this y by itself, almost like it's slope-intercept form. So we're converting from this to this. So I'm going to distribute the 3, and that's going to give me 3x minus 3, and then I'm going to add the 2, and I'm going to get y equals 3x, moves down a little bit, 3x, and then if I add it to minus 1. All right, so that's like, mx plus b form for a line, but remember with these sequences, we usually describe them as some letter sub n. So the nth term, that's going to like replace the value of y. And instead of x, as you guys remember, we're not going to use x, we're going to use n. So the nth term is going to be 3n minus 1. And that's it, right? It does have a common difference of 3 because the slope is 3, and the first term is 2. Notice how if I plugged in 1 for n, I would get 3 times 1 minus 1, which would be 2. So that basically like fits both parts of that. So that's kind of how we do it, right? So again, a lot of stuff going on here. You're going to figure out the slope. I'm going to use this formula pretty much exclusively. And you can write that formula down. You have it for your graded activity. And you're going to use this formula. You're going to plug in m, and you're going to plug in your coordinate point based on the first term, knowing the first term is 2 or whatever term they give you. Plug that in. And then once you're done getting y by itself, just replace it with a sub n and replace the x with just the n. And then you are done, right? So this is kind of a little bit more complicated, but we'll be okay, right? So this one says, is that it for this slide? Oh, good. This one says 2, 6, 10, 14, 18, right? So you can see that the common difference between each term is 4, right? So that means like my slope is going to be 4, right? Now I need to know the 54th term. Well, like in this one, it said the first term is 2, so I plugged in 1 and 2 into my formula. This one, it gives me a whole bunch of them, right? So I can just pick any one that I want. I'll just say that the first term is 2, right? So all that means is if I have my formula y minus y sub 1 equals m, which I know is 4, and then x minus x sub 1, I have a whole bunch of stuff I can choose from. I could say second term, 2 for x is equal to 6. I could say third term, 3 for x is equal to 10. But I'm just going to use the easiest one, which is first term. So it's going to be x minus 1, right? My first term, that's my x. And that value is equal to 2. So I'm going to say y minus 2 is equal to 4 times x minus 1. Again, we're trying to get rid of these x's and y's, but I'm going to distribute this first. So I'll just draw an arrow over here. It's going to be y minus 2 equals, and this is going to be 4x minus 4 when I distribute the 4. And then I'm going to add my 2. I'm going to get y equals 4x, and then minus only 2 if I add 2 to it. And so my final answer, I'm getting rid of my y's with my a sub n. That's my nth term. And it's going to be, instead of x, we're going to use that n, 4n minus 2. Right? So that's the formula for it. It's not really what the question asked me, but that's the formula for it, right? It has a common difference of 4, and I can figure out that the first term, if I plugged in 1, would give me 2. If I wanted to plug in 2, I would get 6. If I wanted to plug in 3, I'd get 10. If I wanted to plug in 4, I get 14, on and on and on. So if I need the 54th term, I'm just going to plug in 54, right? So I'm going to get 4 times 54, which is a big number. And then I'm going to subtract 2 from it, right? So 54 times 2 would be 108. And if I doubled 108 again, I'd get 216. And then minus 2. So the 54th term would be 214. And that's basically the nuts and bolts of an arithmetic sequence.